Hello class. Example A, starting with section 7.2 screencast notes. Find the horizontal and vertical scale factors of the parabola at the right, the vertex 4, -2, and write its equation. Then rewrite the equation with a single scale factor. So, we definitely know how to write this with the vertex in vertex form and finding scale factors. We have done this a couple units ago. Remember, this is the equation y equals b times x minus h over a squared plus k. H and k is the vertex, and they're telling us that that's 4, -2. So I already know that x minus 4 squared and k is -2, so -2. So then I use this graph over here to find the horizontal and vertical scale factors. So I made a bigger version of that, not that it's much clearer, but at least it's a little bit bigger for me to write on. And we know we start at the vertex and we pick another point on the graph, and then we count how much up and over. And when we go over, that's our horizontal scale factor, and when we go up, that's our vertical scale factor. So if I'm going over from 4 to 7, that's a horizontal scale factor of 3, and up from -2 to 4, it's a vertical scale factor of 6. Remember, our horizontal scale factor is our A, and our vertical scale factor is our B. So B equals 6, A equals 3. I'm just going to write that over here. A equals 3, B equals 6. So now I fill that part in my equation, 6 and 3. Now, so this is our equation, and normally when we did our previous chapter, we'd be done right then and there. But this asks us to rewrite it with the equation with a single scale factor, meaning they want us to combine this 6 and the 3 into a single scale factor. So we have to use some of our properties, some exponent properties and other properties in order to combine these together. So I'm going to get to a new slide and recopy this equation to have a little bit more room. So y equals 6 times x minus 4 over 3 squared minus 2. So the first property of exponent I'm going to use is I'm going to take this exponent and distribute it to the numerator and denominator. Okay, we've seen this before with if we've had 2/3 squared, this is allowed to be 4 squared over 3 squared. So I'm going to do the same thing. So this will rewrite y equals 6 times x minus 4 squared over 3 squared minus 2. Okay, so now I can use multiplication, and I'm going to multiply 6 times my parentheses. So I get y equals 6 times x minus 4 squared divided by 3 squared minus 2. So from here, I can do 3 squared, and I'm going to just pull that out and put it under the 6. So I have 6 over 9 times x minus 4 squared minus 2. And now I have that single scale factor that they were asking me for. 6 over 9 is my scale factor. That reduces, though, to 2 over 3. So my single scale factor equation, y equals 2 over 3 times x minus 4 squared minus 2. And this is the same exact equation as up here, but instead of having the two different scale factors, I have one single scale factor. Now you might have picked up on a simpler way to do this. You can simply take the denominator scale factor, square it, and then move it outside and divide 6 by it. And that would work with any quadratic equation. And we'll see some examples of that in our next class. So, moving on to example B. Let me put in the picture, zeros, here we go. Okay, so find the zeros of the function y equals negative 1.4 times x minus 5.6 times x plus 3.1. So this is in factored form here. So this is factored form. You can only find zeros when you're in factored form. So let's just take a couple of notes first. Zeros of a function, this is probably the first time you've heard this word, zeros of a function are values for x that will make y equal 0. Go figure why they're called zeros of a function. You can use use the zero product property. Oh, I didn't mean to cross it out, I meant to underline it. So the zero product property says if A and B are real numbers and A times B equals 0, then either A has to equal 0 or B has to equal 0. Okay? So, how does this apply to this problem that we have up here? Well, we have a whole 3 different sets of terms being multiplied together. So, in this case, I'm going to erase what's on here, so make sure you have that copied. So in this case, y equals negative 1.4 times, so this could be A, times x minus 5.6, which is our B, times x plus 3.1, which is our C. So if this whole thing is going to equal 0, because y has to equal 0, then either A has to be 0, B has to be 0, or C has to be 0. Why? Because anything multiplied by 0 gives 0. So let's write this one out. So we would say that, so either negative 1.4 has to equal 0, or x minus 5.6 has to equal 0, or x plus 3.1 has to equal 0. Well, negative 1.4 equaling 0, this is not possible. So this guy's out. X minus 5.6 equaling 0, well, I can solve that for x by adding 5.6 to both sides. So x could be 5.6. Here's one solution. Or this last one here, I could subtract 3.1 from both sides. So x could equal negative 3.1. So the zeros, or the solutions, or what are called roots of a function, are x equals 5.6 or x equals negative 3.1. So let's write that down on the bottom. So the zeros, which are also solutions, which are also known as roots of a function, are x equals 5.6 or x equals negative 3.1. And that's our solution for finding the zeros of that function. Now we can also find the zeros if we're given a graph. So if I have a graph like this, okay, I can find the zeros here. So the zeros, or roots, are, remember, when y equals 0. So where does y equal 0? Here and here. So the zeros, or roots, are x equals -3 and or x equals 2. Over here, the zeros, or roots as they're known, we have here, x equals -3 or x equals 4. Okay, so with those zeros or those roots, we could actually turn around and write that into an equation. Once we have the roots, we know that to get those roots, I must have solved for x. So an equation here in factored form is just y equals, how would I have solved for x and gotten an answer of -3? Well, I must have had x plus 3, because when I set that equal to 0, to solve for it, I would have to subtract 3 from both sides. And here must have been x minus 2, because in order to solve for 0 there, I'd have to add 2 to both sides and get x equals +2. And I'll show you that on the next slide. Here, the equation, can you guess it? Y equals x plus 3 and y equal, whoops, sorry, not equals, and y minus y. What am I doing? Y, not y, no y. And x minus 4. So what we put into factored form is the opposite of what our zeros or our roots are. Okay? So let me just show you for a second. I'll prove that, let's say the x plus 3 and the x minus 2 give us these zeros or these roots. So if I have that equation, y equals x minus 3 and x plus 2. Let me make sure I copied it right. Nope, I didn't. See? X plus 3 and x minus 2 is what I had written on the other page. Okay, so here's my factored form equation. So if I'm going to find roots, right, I would set this whole thing equal to 0. So either x plus 3 is equal to 0 or x minus 2 is equal to 0. When I solve, I subtract 3, so x equals -3. And when I solve here, I add 2, so x equals +2. Which, if I go back, there are my roots, -3, +2. Okay, so there's that one. On to our last example, which is 3 different forms. Nope, that's not it. Cancel. 3 different forms of, that's what I just had up. Oh, tell me I don't have it. That'll be annoying. Hold on. No. Cut. Where are you? Here we go. Okay. So consider the parabola at the right. Write an equation of parabola in vertex form. Write an equation of the parabola in factored form, and then show that both equations are equivalent by converting them to general form. So vertex form, remember, is, so this is A, so y equals, we have b times x minus h over a squared plus k. So vertex form, finding the vertex, first of all I look, it's here at 1, -4. So there's my h and k. Finding another point on my graph, I'm going to go right here. It's up 1 over 1. So my A is 1 and my B is 1. So filling this in, y equals 1 times x minus 1 over 1 squared minus 4. If I'm going to write it as a single, write my scale factor as a single factor like we did in example A, I'm going to take the denominator, I'm going to square it, and then put it out under here. So I'll have y equals 1 over 1 squared times, now I keep the numerator, x minus 1 squared minus 4. And when I simplify this, 1 over 1 squared, that's just 1, so I don't even need to write it. So I simply get y equals x minus 1 squared minus 4. And that is the answer for A. That is vertex form. Okay, let's look at B. I'm going to erase this, so pause or rewind as needed, because I need to use this graph again. So, looking at B now, write the equation in factored form. So that's what we just did in the last problem, where we have to find our zeros first, or our roots. So we find those where y is equal to 0. So right here, well, that wasn't a very good circle. Let's try that again. Right here and right here. So here x is negative 1, so x equals negative 1 is one root. And here 1, 2, 3, and x equals positive 3 is the other root. So the equation here is y equals x plus 1 times x minus 3. Again, to write this equation, I'm just taking this and changing it to the opposite when I put it in the parentheses, so that when I solve, I'll get the root back. So there's my answer for B. Okay, so now a little bit more of a tricky part. So C says, show that both equations are equivalent by converting them to general form. So general form, if you recall from a couple of screencasts ago, is when we have ax squared plus bx plus c. We were using that when we were factoring. So I'm going to go one screen over. So general form is when we have a number times x squared plus another number times x plus a constant, and this is all equal to y, of course. So that's what I'm looking to get these equations in. So I'm going to start with vertex form. So vertex form, at the end of my problem, vertex form was written as y equals x minus 1 squared minus 4. So we know that squared means that I have that set of parentheses twice, x minus 1 times x minus 1 minus 4. So I'm going to either FOIL this or use my area model to multiply. So if I FOIL, I have x times x, which is x squared, and x times negative 1, which is negative 1x. I have negative 1 times x, which is negative 1x, and negative 1 times negative 1, which is a positive 1. On the end here, I'm just bringing this down, minus 4. And now I combine like terms. So like terms, negative 1x, negative 1x, so y equals x squared, negative 1x, negative 1x, negative 2x, and 1 minus 4 is negative 3. And now you can see here's my A, here's my B, and here's my C. So this is vertex form in general form. Moving over and looking at factored form. Factored form, we're just going to do an expanded form. So I had y equals x plus 1 times x minus 3. Just make sure I remember that correctly. X plus 1, x minus 3, perfect. And now again, I can FOIL like I did over here on vertex form, or I can use area model. So I'll do this one in area model just to show you a different way, right? This would be x and 1. This would be x and negative 3. So this would be x squared, this would be negative 3x, this would be 1x, and this would be negative 3. And let me add all my terms together. So y equals x squared minus 3x plus 1x minus 3. And when I combine my like terms here and here, I get y equals x squared minus 2x minus 3. And now I have both in general form, and since I was writing an equation for the same graph twice, notice that both of these guys are the exact same, x squared minus 2x minus 3. So the last note I want you to take is just to have a copy of the three different forms. Three forms of a quadratic function. Okay, so three forms of a quadratic function. We just talked about them. We have general form, which is that y equals ax squared plus bx plus c. There's factored form, which is y equals a times x minus r1, x minus r2. So let me explain for a second what these are. This is your single scale factor. This is a root, and this is another root. So that's where we were getting them from the graph. And then last but not least is the one that we've known for a while now, vertex form. But this vertex form is written with a single scale factor. So instead of having the b and the x minus h over a, they write it now as a times x minus h squared plus k, where this, just like above in factored form, is your single scale factor. Okay, so hopefully you took some really good notes. We will use these in class on, the next time I see you, and of course you will have your quiz. Okay, see you then.